Okay, so the practice test for linear and quadratic systems and inequalities. If we look at question number 1, the x-coordinate of the point of intersection of these graphs with the two equations are. So the tricky part when you're graphing these is being able to get your window settings and being able to see things within your window setting. It creates adjustments and then you might have to adjust again. Use the table of values to help you with that. If you grab your calculator and if you had put the two equations into the calculator, I'll get that afterwards. So x squared plus 15x minus minus 20. And then 5x squared minus 13x plus 29. And then I think I've got my table set on ask. So if I change it to auto and I go to my table, what I'm looking for is right here. The y1 value is less, it's less, it's less, it's less, it's less, it's less. Then it jumps up to being it's still less. So I'm looking to see if there's any changes and where those changes come through or where there could be a point of intersection. I can try from there first, or I can just try graphing it. So if I go zoom 6 and I look at a normal window setting, there's one of my quadratics, which I can't see very much of the rest of it. Can't see much of anything. So maybe I need to adjust my y's, or maybe I need to adjust my x's. So if I adjust my x's, say if I start with 20 and 20, and graph that and see what it looks. Okay, well now I'm seeing one quadratic, but I still haven't seen the other quadratic at this point in time. And again, if I look at my table of values, it might have something to do with where my y values are at. X is equal to 2 and y is equal to 23. So now instead, if I adjust my y values, and let's say if I go up to 50, and there's my second one is right there. So I just needed larger y values. And it looks like the intersection point is in here. So if I wanted to, I could get rid of my x part, start at 0, and maybe even just go up to 10. And then maybe again increase that y value and maybe go up to 80. And now I get to see a better intersection point. Okay? Does that make sense now? So what intersection point do I have? D, 7 halves. Okay. If we look at B, to the nearest tenth, the sum of the x-coordinates of all points of intersection to the system. So if I look at the two intersection points, I would have one intersection point was at negative 0.828, and it went on and on and on, and 4.828, which went on and on and on. And it's the sum of the two coordinates, so if I add these together, all of this decimal stuff disappears, and it leaves me with 4. Okay? Question number 2 is tricky, because when you go to graph this, your window settings will become important again. So if I graph in my first quadratic, x squared minus 2x plus 3, and then my linear x minus 5. And if I had chosen a standard window setting, there's my quadratic, and there's my linear. And I have to imagine what happens if I extend this out. Are these ever going to intersect? No. So how many solutions? If they never intersect, is there a solution? 0. Okay. If I wanted to look at this algebraically, x squared minus 2x plus 3 equals x minus 5. If I bring the x over, I would get x squared minus 3x plus 8. And off the top of my head, I can't think of two numbers that multiply to 8 and add to 3, negative 3. So then I start using the quadratic formula. But before I get into the quadratic formula, I'm going to check the discriminant, because that stuff under the square root sign helps me right away with the number of solutions. So b squared, that's going to be negative 3 squared minus 4 times a times c. And when I do that, I get 9 minus 32, which is a negative 23. I can't take the square root of negative 23. So again, there's no solution. Okay, so there's two ways that we could look at this. We could have looked at it from an algebraic approach. Okay, when solving this system, as follows, a quadratic equation which requires to be solved is, so in other words, how can I do this algebraically? So if I did this algebraically, I can let the two sides equal each other, because if y equals this and y equals that, then y would be the same in the solution. And bring everything over to one side, and I would get 3x squared minus 3x minus 1. Is that correct? So then I get B for my answer. Question number 2, to the nearest hundredth, the positive x-coordinate of the solution to the quadratic system of equations is, when you see something that says to the nearest tenth, to the nearest hundredth, okay, let's continue. So again, as I was saying, when you see something that says give your answer to the nearest tenth, the nearest hundredth, use your graphing calculator and get your intersection point from there. So when I graph these two, I would get a positive and a negative intersection point. I'm only concerned with the positive, which is 1.17. The negative was negative 0.17, but I don't even need to look at that one. Question number 4, the line y equals k times x plus 3 is tangent to the parabola. What does tangent mean? It only touches in one part. So if I was to solve this algebraically, it means I have k times x plus 3 is equal to x squared plus 8. So I move everything over to one side, and I get a negative kx plus 5. Now, if it's tangent to one part, that means it only touches in one spot, which means there's only one solution. So if there's only one solution, we have to go back basically to solving quadratics. When is there only ever one solution? So think of when I solve a quadratic, so solving a quadratic, finding the zeros in a quadratic system, I can have no zeros, which means the quadratic didn't intersect at all. I can have 2 zeros, which means it went through the x-axis. And then I can have 1 0, where it intersects at one part. Where it intersects at one part is usually, like, it's like a perfect square, which I know I can't have here because 5's not a perfect square number. But in terms of the quadratic formula, when we were looking at the discriminant, which we looked at in the previous question, when I have no solution, the discriminant is negative. When I have 2 solutions, the discriminant is positive. And when I have one solution, the discriminant is 0. So that means that b squared minus 4ac is equal to 0. If I solve for that, I will get my value of k. So b is k, so I get a negative k squared minus 4 times 1 times 5. So that gives me k squared minus 20 equals 0, and k squared equals 20. So k equals the square root of 20. which right now doesn't match any of my answers, but then I look, can I simplify the square root of 20? So does 20 contain a perfect square factor? 4. So 4 times 5, so this would become 2 root 5. Okay? Other ways that you could solve this question, when you get to this point, you could actually substitute it in, or what you could have done too is you could have substituted each of these 3 values in for k, and then graphed all 4 of them, all 4 results, to see which one showed a tangent line to the parabola. It's time consuming, but it could have been done. Okay. Question number 3 says the quadratic systems of equations is satisfied with the values of x equals 4 and x equals 6. So then what's the value of k? So what it means is if I start to solve this algebraically by letting the 2 sides equal each other, and then bring everything over onto one side, I get x squared minus 10x plus 3 plus k equals 0. And then what I have is I have that the quadratic is satisfied by these 2 solutions. In other words, what that means is this quadratic here should actually be the same as the quadratic that's formed by the 2 zeros. If x equals 4, it means I have a factor of x minus 4. If x equals 6, it means I have a factor of x minus 6. So if I expand this out, x squared, negative 6x, negative 4x, plus 24. So this is the same. This is the same. So I now have 3 plus k equals 24, which means k would equal 21. Does that make sense? Okay. Question number 5, the point which is not in the solution region of the following inequality is. So how did you guys do this question?
I graphed it.
You graphed it? Okay. So if I graph it, 3x minus 2, so I get 3/5 x minus 2/5. So then if I was to graph that equation, so I'm going to graph 3/5 x minus 2/5. Zoom standard. So then if I look, and this has to be y is less than. So if I change that to be an arrow down, because that's less than, there's my shaded in region for me. So now if I start looking, the point 3 and negative 5, 3 over, negative 5 down is in the solution region. Negative 3 and negative 5 is in the solution region. Negative 3 and positive 5 is up here, not in the solution region. And then the last one, which is 5 and negative 3, is in the solution region. Okay? The other way that you could have done this is you could have substituted in the x and the y values for each of these and just checked to see which inequality was true or false. So you could have used the graph and then gotten c from there, and then if you wanted to, you could have double checked it. 3 times negative 3 is negative 9, minus 25 gives me negative 34, which is not greater than 2. So the answer to this one was C. Okay, the next question, when solving the system, y equals 2x squared minus 3x minus 6, and y equals 7 minus 4x, a quadratic equation is formed which requires to be solved. If this equation is written in the form of 2x squared plus bx plus c, what is the value of b and c? So let the two sides equal each other, and I isolate, bring everything over onto one side, so I make the equation equal to 0. So I get this. B value is equal to 1, and the C value is equal to negative 13. So then B minus C is 1 minus negative 13, which is 14. Okay. Question number 6, which of the following points is in the solution regions of both y is greater than 2x plus 8 and y is less than or equal to x squared minus 3x plus 2? So how did you solve this one? Graphed it. Did you graph both of them at the same time? And did you shape both of them at the same time? So to see what that would look like, let's see. Y is greater than 2x, or not 2x, 2x plus 8. So 2x plus 8, and y has to be greater than that, so it's going to be the up arrow. And then I have y is less than, so that's the down arrow. And that is x squared minus 3x plus 2. So when I graph it, there's my linear, and there's my quadratic. So the following point that is in the solution region of both, if I look at, so I probably have to adjust my window settings so that I can see up to 20, because that was one of my solutions. So I'm going to go up to 25 and regraph this. So the solution region is the region where it's double shaded. So if I look at 0 and 10, I only have one that's in the solution region, so it's not in both. If I look at negative 1 and 6, that one's kind of hard to tell. I might have to go back to that one. Negative 2 and 4. So I wonder what happens. If I go trace and I go negative 2, does it look like it's in both regions? Okay. If I try negative 1, so maybe if I go back on my window settings again, so I'm going back and forth, but it might help because then I can see my tick marks a bit better. So now if I type in negative 1, oh, where? Go back here, trace, there we go. Negative 1. It's hard to say whether or not it's actually in both solution regions. I may need to check that or zoom in. How did you do it, Evan?
Well, I just did the last one. The last one's like for sure. So
the last one's for sure? So negative 2, 3. You could probably look at the table of values as well and compare with my negative 1. So the negative 1, even though it's a solution, the problem that happens is this isn't equal to. So it's the solution for one of the points, but it's not actually a solution for this one. And then when I look at 2, I get, if x equals negative 2, I'm going to get 4, which satisfies this one, but I don't think it satisfies the other one. And the other way is just double checking these by putting them into charts. So I could double check this. If I put in negative 2, I'm going to get 4 plus 6 plus 2. And then on this one, I'm going to get negative, so this one I get 4 and 4, which doesn't work again because it's not equal to. So that's what eliminates C. Okay? Question number 7. The illustration shown is a screenshot from a graphing calculator, and the parabola on the screenshot has the following equation. The shaded region represents which inequality? So which solutions can I automatically eliminate before I even start?
Equal to 1.
The equal to ones. C and D are automatically eliminated because this is shown with a dotted line. And then from there, I could use my graphing calculator to help me figure out the rest. Or I could pick this test point. I have a test point of 0 and 0. If I plug that into the equation, I'm going to get 0 and negative 11. It's not in the solution region, which means I need to make this false. So to make it false, I would write that 0 is less than negative 11, which means y is less than the other side. Okay. So I'll do 8 and 9 and then we'll stop. Stephanie graphed an inequality on his on his calculator. The x and the y-intercept of the straight line are 2 and negative 4. So what's the line of this inequality? So how could I solve this? This is a y equals mx plus b. And I have that this point here is at negative 4 and this point here is at 2. So negative 4 becomes my y-intercept. And then my slope I can calculate, rise over run. I have a rise of 4 and a run of 2. 4 over 2 gives me a slope of 2. So I get 2x minus 4 equals y. And if I notice, my equations here are written in general form or written with the y over on the other side. So I'll rearrange this, put the y over, and it's going to equal 4. And then I'm going to pick my test point. So I know that 0 and 0 is in the solution region, so that's what I'm going to plug in. So 2 times 0 is 0, minus 0 is 0. So I get 0 and 4. I want to make this true. So to make it true, 0 is less than 4. So the one that has a less than would be B. Okay. The last question, the shaded area shows the solution region to a 2-variable inequality. The x-intercepts are at negative 5 and 2. So negative 5 and 2. And the y-intercept is at 30. So the 2-variable inequality is what? So these 2 points right here can help me write my factors of x plus 5 and x minus 2. That intercept of 30, I have to think about that coefficient, that a value. So this is how I could start off by writing out my equation. I don't know what the value of a is. I do know that it should be negative because it's opening upside down. So then I can substitute in when x is equal to 0, y is equal to 30. So I get 30 equals negative 10a. So that means a would equal negative 3. Put that back into my equation, and y equals negative 3 times. If I expand this out, I will get x squared plus 3x minus 10. So now I get negative 3x squared minus 9x plus 30. And then to figure out which inequality to use, well, actually, so at this point, I've eliminated A, and I've eliminated B, right? So that leaves C or D as my possible choices. So if I take my test point, 0 and 0, I get 0 and 30. And to make that true, I would have to write it as a less than or equal to, which is not what C is. C is a greater than, so that means that it has to be none of the above. Okay. Okay, question number 10 asks, the shaded region represents the solution region to the inequalities, and it asks you to identify which inequalities they are. So you've got the two equations. The equation opening upside down is negative 2x squared minus 5x minus 6. So what you could do with your graphing calculator is you could check to see if I make this a y is less than, does it shade the inside region or does it shade the outside region? So when you do that, what you get is that y is less than or equal to negative 2x. So this one right here becomes a less than or equal to, which then eliminates B and D. And then you can do the same thing with the 2x squared plus 5x plus 1. Again, graph it and then check to see is it a greater than or a less than. And this one here is a greater than or equal to. So then C ends up being your choice. Okay? So if we look at numerical response number 5, a dinner theater is putting on a new show with a maximum capacity of 125 guests. Each guest will pay $75 to attend the show. The expenses each night can be related to the number of guests by the following formula. So it says the number of guests that must attend the show on any particular night in order for a profit to be made can be written as K is less than or equal to N, which is less than or equal to 125. So the value of K is what? So if I grab my graphing calculator and I take a look at this, if I graph in my first equation, which is that 1800 plus 39n minus 0.15n squared. Now when I go to graph this, I am going to have to adjust my window settings. So if I take a look at my table of values, I can see what the amounts are. At 0 people, I'm at $1,800, and it just goes up from there. And I actually have to go up to 125. So what I could do is I could scroll down to 125 and take 5 minutes. Or if I went to my table set and went to independent and then went to my table becomes blank. So I can go from 0 guests, which is 125, or sorry, 1,800, to 125 guests, which is $4,300. So now I know that my Y values need to go up to about 4,500, and my X values need to go up to 130. So my X's have to go up to 130. I can go up by tens. And then my Y's need to go up to about 4,500. And I could go up by 500s. When I press graph, I'm going to see this curve. Okay? But that's only part of the graph. I still need another portion. I need another line. And that other line comes in what the guests are paying. So this is my cost. This is my expenses. Now I need to figure out what my revenue is. So my revenue is $75 per guest, where X is, or N is the number of guests, so it should be 75N. So now if I put that into my graphing calculator in Y2, so 75X, and I graph it, there's this straight line. So what I would want to do is I'd want to find out what this intersection point is. This intersection point would tell me the number of guests, because after that, it's this part in here that gives me the profit. Any of these guests above this number, I'm making more money than I'm spending. That curved line is the amount that I have to spend. The straight line is the amount that I'm taking in. So if I find that intersection point, I get 42.48. So how many guesses do I need? 43. 42 guess is not going to be enough. I need to round this up. And I could check this by putting 42 into both equations. And again, I could use my calculator to help me with that because in my table, I'm at ask. If I went down and I typed in 42, my expenses are still more than my revenue. But if I type in 43, it flips around. So it does make a difference. The rounding in this case does not follow our normal rounding rules because of the context of the question. I can't round down to 42 people. I have to go up to 43 in order to make that profit. Okay? You could also solve this algebraically by letting 75n equal this and then putting everything onto one side using, I could use the quadratic formula to help me solve it. Or what I could do is I could get one equation and graph it and then find the zeros. That would also work. Okay? Question number 11. The solution to the inequality x squared minus x minus 90 is greater than or equal to 0 is what? So how could you solve this question? What did you do to solve it?
Sign chart.
Sign chart. So in order to do the sign chart, I need to factor this. So what does this look like when I factor it?
X minus 10.
So then what are my zeros?
10 and
10 and negative 9. So I've got all the numbers up to negative 9, or actually all the numbers less than negative 9. I have negative 9 itself, all the numbers in between to get to 10, and then all the numbers greater than 10. And then I have my two factors. I have my x plus 9 and my x minus 10. So this is what my sign chart ends up looking. I just put my factors on the other side. So when x is equal to 9, I get a 0 here. Anything greater than negative 9 gives me positive answers. And anything less than negative 9 gives me negative answers. With my 10, I get a 0 there. Anything greater than 10 is positive. Anything less than 10 would be negative. And then I put in my product. That's what's at the bottom. So two negatives gives me a positive. This would be a 0, a negative, a 0, and a positive. So the solution to the inequality that's greater than 0, that's these positive ends. So that's the values that are less than or equal to negative 9 and greater than or equal to 10. So the answer would be C. I could also graph this, and if I graphed it, I'd get this quadratic that went through negative 9 and positive 10, and I would be looking at the parts that are greater than 0. So that's this section and that section. So it still gives me the same answer, doing the sign chart or doing the graphing calculator. It says, consider the number line shown. The inequality represented by the following number line is what? So if I look at these, they're shown as factors. So first of all, if I have x minus 5, what would the factor be? X plus 5. And then the negative 2 would become x plus 2. So that eliminates A and B. Okay? This quadratic, does it open up or down?
Up.
How do I know?
You'll end up with a positive x squared.
My x squared is going to be positive. So if I think of what this would look like graphically, it's going to go through -5 and -2, and it's going to go up. So then the solution that's between 5 and 2, that's this part here, that's the part that is less than 0. So my answer would then be C. Okay. If we take a look at question number 13, Hanif is algebraically solving the following inequality. His teacher tells him he can only evaluate this for 3 values of x. Which of the following values of x should allow him to determine the correct solution to the inequality? So if I look at this, what I would want to do is I'd want to factor this out. And if I was factoring this out, I would probably rearrange this. I would take out a 3 to start off with, and I would rewrite this as x squared minus 7x plus 6. And then I would factor this part out. So if I factor this out, I get 2 numbers that are equal to 6 and add to -7. So my 2 numbers would be
-6 and
So then what are my 2 zeros?
6 and 1.
6 and 1 are my zeros. So then if I think about my chart is going to have all the values that are less than 1, all the values between 1 and 6, and all the values that are greater than 6. So if I look at where -9, -3, and 0 go, well, they all go in this line here. I want something that is going to be able to be spread out. So really what I want is I want numbers less than 1. I want numbers between 1 and 6. And I want numbers that are bigger than 6. Because in this chart in here, I'm going to get a 0 at some point. So what I'm trying to do is I'm trying to figure out what the sign would be in each of those intervals. So if I look at 0, 3, and 9, I've got 0, 3, and 9. It's in each column. Whereas if I look at 2, 3, and 4, all 3 of them are in the middle. That's not going to help me determine what these 2 end pieces are going to be for their signs. -2, 3, and 5. -2 fits here, but 3 and 5 fit here, so I'm still missing 1 for the outside. So that was the purpose behind the question, was to see if I was to use test points or actual values, which values would I need to consider in order to find the signs of these 3 interval places. Okay? The next part looks at questions 14 and 15. So Corey's solving the quadratic inequality, -5x squared minus 5x plus 30 is greater than 0 using a sign chart. The outline of her sign chart is shown. So what we want to do is we need to figure out what these values are. So first of all, what's the value of P? And what's Q? 2. Because I want them to be in numerical order. That's why P is -3, and that's why our Q is 2. So now if I was to fill in the sign chart, because chances are I'm going to need to fill it in anyways, this -5 is a constant, which means it doesn't matter what the value of x is, that's always going to be negative. So whenever you have a constant and you put it into you have to put it into your sign chart. Especially when it's negative. If it's positive, it's really not going to make an impact, but if it's negative, it needs to go into that sign chart. And then with my +3, there's my 0. So my x plus 3, my 0 is at -3. Anything bigger than -3 gives me a positive value. Anything smaller gives me a negative. And then at x minus 2, My 0 is over here. Anything bigger than 2 would be positive. Anything smaller than 2 would be negative. So then if I look at my products afterwards, these two are zeros. This here is going to be negative. This column in the middle would be positive, and the outside one would be negative. Okay? So which of the following statements is true? So P has to be equal to -3, so that eliminates A and B. Q has to be equal to 2, so I'm still choosing between C and D. And the value of R has to be negative. So that's C. And then the solution to the inequality when it is greater than 0. So when it is greater than 0, that's looking at the positive interval, which happens between -3 and 2. So between -3 and 2. So that brings us to our last question, the written response. Question number 1. Describe a method which does not use technology for determining the solution region to the inequality of the form y is greater than ax² plus bx plus c. So if I gave you a quadratic, how would you solve this without using your graphing calculator? What would you need to determine?
You should factor between the zeros.
So I need to find the zeros. Okay, what else would I need? What else would I want to know besides the zeros? What other part do I like you to label on a quadratic? So the zeros are the x-intercepts, the y-intercept. So find the y-intercept. And that will allow me to sketch the quadratic. Okay? And so use these values to sketch the quadratic. What kind of line would I use in my quadratic?
Dotted.
A dotted line. Or a broken line. And that's because it does not include. Okay, so now I have my quadratic drawn. How do I do the next part? Because I need to determine the solution region for it being greater than. So how would I do that?
Use the test point.
Use a test point. And what's the best test point to use? 0, 0. If possible. So I use the test point. And then what happens if the test point, if it's true?
Then it's within shooting range.
So if it's true, the test point is in the solution region and can be shaded. If it is not true, so if it's false, the test point is not in the solution, so you shade the other region. Okay? So we're going to use this to sketch the solution region to the following inequality. So we need to factor this quadratic. And this quadratic is probably one of the harder ones to factor. We can't factor it by sight because there's too many possibilities. Like to get 6, there's 3 and 2, 6 and 1. And then to get 45, I've got 1 and 45, 5 and 9, I've got 15 and 3. There's just too many things to consider. So I am going to have to use that sum and product chart. The sum is 17, and the product would be 6 times negative 45. So what's 6 times negative 45? So can you think of two numbers that multiply to negative 270 and add to 17? 27 and negative 10. So then I would rewrite this 6x squared as being 6x squared minus 10x plus 27x minus 45. And what can I factor out of the 6x squared and the 10x? And what am I left with? So 3x minus 5. What can I factor out of 27x and negative 45? A 9. And will that leave me with 3x minus 5? Yes. So then I'm left with 3x minus 5 times 2x plus 9. So then what are my zeros?
5/3 and -9.
Good. Okay. And then what is my y-intercept? Negative 45. This is when x is equal to 0. So now I can graph this. I have a negative 45. I have a 5/3. And I have a negative 9/2. So negative 9/2 is negative 4.5. And 5/3 is about 1.7. So the vertex is going to be halfway between. So that means my vertex is somewhere halfway between these two. So when I go to draw this, 45 is not my it's not my low point. It's actually going to go through 45, come down past that, and then go to 92. Okay? Now, should my line be solid or dotted? Dotted. So make sure you draw it as a dotted line. So there's my broken line, quadratic. And then, so that was the first part. I figured out my zeros, figured out my y-intercepts, sketched my quadratic. My second part was to do what? Test point. So what test point are we going to use? 0 and 0. So if I put 0 and 0 into this equation, y is 0, and then I get negative 45 on the other side. So I get the inequality 0 is greater than negative 45. Is that true or false? True. So that means that 0 and 0 is in the solution region. So I shade, this is where 0 and 0 is. So I'm shading all of this stuff in between. Okay? The last part says, explain how to use the graph in the bullet above to determine the solution to the inequality 6x squared plus 17x minus 45 is less than 0. So if it is less than 0, it is going to be the part of the graph above or below the x-axis? Below the x-axis. So if I look at the graph, the part of the graph that's below the x-axis is the part from negative 9.5, or sorry, negative 9/2 to positive 5/3. So the way that we would write that, negative 9/2 is less than x, which is less than 5/3.